It begins as a quiet contest, a cluster of microscopic follicles deep within the ovary, each holding a single possibility, each sensing hormonal signals drifting through the bloodstream like faint instructions. They awaken together, grow together, compete together. Yet only one will be chosen. Dozens begin the race, but only one reaches maturity. Only one receives the biochemical permission to expand, rupture, and release. Only one becomes the center of one of the most precise selection processes in the human body. Why does the ovary choose just one egg when it holds hundreds of thousands waiting in reserve? Why does one follicle surge ahead while the others fall behind? And how does the body evaluate, measure, and decide which egg earns its place in that month's cycle? However, this is not randomness. It is orchestration. Ovulation is governed by hormone rhythms, feedback loops, cellular dialogue, and competition so subtle it unfolds far beneath awareness. Inside the ovary, follicles stretch and shrink, signals rise and fade, and the endocrine system oversees every shift, like a conductor guiding a biological symphony. This is more than physiology. It is refinement, precision, a monthly negotiation between potential and selectivity. Because while many follicles begin the journey, the body must choose only one, not out of simplicity, but out of evolutionary strategy, resource protection, and the need for controlled, stable reproduction. Today, we step inside that selection process, inside the follicle itself, inside the ovary's choreography, inside the hormonal currents that elevate one egg and silence the rest. Let's go inside. To understand how the body selects a single egg each cycle, we must begin where the rhythm truly starts, deep within the brain. The hypothalamus, acting as the system's internal clock, releases pulsatile bursts of GnRH, tiny hormonal signals that set the entire reproductive process in motion. These pulses awaken the pituitary gland, prompting it to send FSH and LH into the bloodstream. Together, these two hormones create the landscape in which follicles compete, communicate, and ultimately diverge in fate. At the beginning of each cycle, a small cohort of follicles emerges from the ovary's vast reserve. Each contains an immature oocyte surrounded by granulosa cells, forming a microenvironment that is exquisitely sensitive to hormonal shifts. FSH stimulates these follicles to grow, but not all respond equally. Their sensitivity varies, determined by the number of FSH receptors they express and the health of the microenvironment supporting them. This variability lays the foundation for competition. As the follicles grow, they begin producing estradiol. This estrogen not only nurtures the uterine lining, but also feeds back to the brain, shaping the next steps of the cycle. Among the cohort, one follicle soon distinguishes itself. It produces more estrogen, expands more efficiently, and responds to FSH more strongly. This advantage reinforces itself. Higher estrogen output stimulates greater blood flow, nutrient availability, and receptor expression. The dominant follicle becomes increasingly prepared to reach full maturity. Meanwhile, the other follicles begin to falter. Lower estrogen output leads to lower support, reduced responsiveness, and eventual atresia, their programmed decline. This attrition is not wasteful. It is protective. The body conserves energy, prevents multiple simultaneous ovulations, and focuses all resources on nurturing the strongest candidate. Inside the dominant follicle, granulosa and theca cells work in coordinated harmony. Granulosa cells amplify FSH signaling, converting androgens into estrogen, while theca cells respond to LH to support steroid production. As the follicle expands, fluid accumulates within the antrum, creating pressure and shaping the structure that will eventually release the egg. As estradiol levels rise, they reach a threshold that triggers a remarkable shift in the feedback system. Early in the cycle, estrogen suppresses LH release, but at high concentrations, it flips the switch, becoming a positive signal. The brain responds with the LH surge, a dramatic hormonal wave that signals the ovary that the egg is mature and ready to be released. Inside the follicle, the LH surge initiates a cascade of cellular changes. Enzymes activate to weaken the follicular wall. Prostaglandins increase vascular permeability, enhancing pressure buildup. Cumulus cells swell, forming the cumulus oovarus, a delicate structure that will cushion and carry the egg out of the ovary. The oocyte itself undergoes the final steps of maturation, a resting in metaphase of meiosis II, waiting for the possibility of fertilization. While the dominant follicle reaches its peak, all other follicles have already exited the competition. Their decline makes space for the final steps of ovulation and ensures metabolic energy is directed towards supporting the chosen egg and preparing the reproductive tract. The dominant follicle now spans nearly 2 centimeters, an enormous structure relative to its microscopic origin. Its wall is stretched thin, its chamber full, its enzymatic activity building toward rupture. The timing is precise, coordinated, and shaped by hormonal cues traveling between ovary and brain in a feedback loop of extraordinary sensitivity. 24 to 36 hours after the LH surge, the system reaches its critical moment. The follicle has prepared for weeks, the endocrine system for days. Ovulation approaches, not as a spontaneous rupture, but as the culmination of cellular choreography and hormonal conversation. Ovulation's climax is not the rupture itself, but the orchestration behind it. The moment when hormones, enzymes, pressure, and timing align with near-surgical precision. As the LH surge takes hold, the follicle enters its final transformation. Collagen fibers loosen under enzymatic influence. Blood flow increases, swelling the follicular wall. A small predetermined zone, the stigma, thins as pressure builds inside the antrum. What appears from the outside as a simple release is inside a controlled unsealing. When the stigma finally gives way, the egg emerges surrounded by its cloud of cumulus cells. This soft, gelatinous halo protects the oocyte as it leaves the ovary, guiding it safely into the pelvic cavity. The fimbriae of the fallopian tube sweep the egg inward in delicate, rhythmic motions, capturing it within minutes. Inside the ovary, the empty follicle does not collapse into silence. Instead, it undergoes one of the most rapid transformations in reproductive physiology. Blood vessels grow, cells reorganize, and the follicle becomes the corpus luteum, a temporary endocrine gland that secretes progesterone. This hormone stabilizes the uterine lining, preparing it for potential implantation, and ensures that the cycle continues with order and purpose. Meanwhile, the other follicles have already faded. Their retreat is not loss. It is strategy. Their absence ensures clarity, timing, and biological efficiency. The system selects one egg because precision matters, because resources matter, because reproductive stability matters. Ovulation, seen from the inside, is a monthly masterpiece of coordination. It is not random. It is not simple. It is not just the release of an egg. It is the body choosing one path forward out of thousands of possibilities, conserving energy, protecting future fertility and sustaining the rhythm that has shaped human life for millions of years. In this delicate sequence, awakening, selection, surge, rupture, the ovary demonstrates a kind of quiet intelligence, a capacity to measure readiness, respond to signals, and adjust with remarkable nuance. Ovulation is a reminder that even microscopic decisions carry weight, that every cycle holds a story of potential, precision, and possibility. A story of how the body chooses one egg to carry the chance for a beginning.